Hey guys, it's Tech, and in this video I'm going to show you how to fix an LCD TV that stopped working after a lightning strike. If the lightning strikes outside, it can enter your coax cables to your cable box through your HDMI cable, knocking out your main video board, which is usually the CPU board. Or the surge can travel through your power lines, through your wall outlet, through your surge protector, and sometimes your surge protector is not strong enough to protect you, and through your power cable, knocking out your main power supply board. So if you have no red standby light on the front panel of the TV, which is right here, it can mean one of two things: bad power supply board or bad main video board. Or actually, it could be both. It depends how bad the surge is. So I'm going to show you the easiest steps to take to troubleshoot and find out what board to replace or what parts to replace. But what you're going to need now is your meter. And if you don't have a meter, you can just switch out the power supply board at shopjimmy.com. It's maybe like 60, 75 bucks, and they have a warranty. And you can see if that fixes your TV. If it does not fix your TV, you can return the board back to them. They'll probably have a restocking fee, maybe like 10 or 15% or something like that. And then you can order the main video board. Or if you want to be better safe than sorry, you go order the main video board and the power supply board, and most likely that should fix your problem if you have no red standby light in the front panel of the TV. And this main video board is usually like 100 bucks. And the power supply board could be like around 50 to 75 bucks. So about like roughly estimate $150 to fix most TVs. Whereas if a technician comes out, they're probably going to be charging you anywhere between $250 to $300. So you're saving 50% off fixing your own TV. So for others that are more advanced and you want to fix it even further and learn something, and save even more money, then you want to have a meter handy and a soldering iron and some solder and stuff like that ready. So let's go ahead and put our meter in AC mode. So that's the V with the squiggle at the end of it right there. And you want to check your input volts. So here's my power cable coming into my power board, and its job is to convert AC to DC volts and going to the main video board. So the power supply job is to energize all these other boards, and also to keep the main video board in sleep mode. So when you hit the power button on the TV, it first goes to this board, the main video board, which is the brains, the CPU board, and then it sends a signal to the power supply board for the high voltage to turn on to energize the rest of the boards. The backlight board, which gives you the brightness. So if you have no brightness on your TV, then you would check your backlight board, which is your inverter board. And that's if you have no brightness. Let's say you have a brightness but no picture, then I would check the TCON board, which gives you the image. And that is directly connected to the LCD panel through these ribbon cable connections right here. But if you have lines in the screen or distortion, it could be your main video board or your TCON board. So when you hit the menu button on the TV and the menu comes up and the menu looks all distorted, it could be a bad LCD panel or a bad TCON board. But let's say you can hit the menu button on the screen, and the menu screen itself, the image, the square, looks okay, then replace the main video board. So if you have no red, in this case, we have no power and no red standby light. So it could be power board, bad power board, or bad main video board. First thing you want to do is you want to check your AC volts coming in. So you want to put one lead right here in the plug of the AC plug, and put another one right here. You should get 120 volts. So right here we have 120 volts, so the AC coming in is good. Next thing we're going to check is the bridge rectifier. Its job is to convert AC volts to DC volts. So I pulled out the power supply. I'm going to be testing the bridge rectifier, which changes to AC volts to DC volts for the board. And right here at the left pin, there's the plus sign, and on the other side is the minus sign, and that's the DC output. The two inner legs is the AC input. So we're going to flip it upside down and test these four legs right here. So you have to take it out of circuit to do that. Now we took it out of circuit. I'm going to break all the pins free. So I put my red lead at the end, and then my black lead right there in the next pin. And I should read about 0.3 to 0.7 is normal, and that's right between 0.3 and 0.7. It's good. And 0.5 is good. And 0.9 is not so good. So I'm probably going to be switching this bridge rectifier out. And then I'm going to switch, and I got my black lead right here, and I run across. OL, that's normal. OL, normal. And OL is actually a normal reading right there. So it should read voltage one way and not the other. But I'm going to switch this out because you shouldn't be getting 0.9. So I'm going to change out my bridge rectifier. So the cable right here going to my main video board, that's my standby volts, and that's what keeps the CPU in sleep mode until you hit the power button, and then all the high voltage turns on. That's really important. So you can read the standby volts on your main power board. In this case, it's going to be a little trickier because it's tight, but you'll know it's right. It's labeled STB right there. That's my standby volts, and you want to put your black lead on ground, or you could check it directly on the main video board. It's labeled right here, 5V STB. That's not my standby volts. That's my standby volts right there. GND is my ground. So I want to test those two pins, and I pushed two paper clips right there. Make sure they don't touch, by the way. And then it makes it easier for me to test that plug. So I'm going to check the standby volts right there. So we're going to test these two pins right here. So I got my one pin, and then my other, and I'm getting 0 volts. So now that we know that there's no standby volt coming into the main video board, we know that the problem is probably most likely the power supply board. There's a bad part somewhere on this board, or parts. So usually what I check is the voltage regulator, the transistors, some diodes, capacitors. So if the capacitors are swollen right here or bubbled on top, I automatically replace those. So I want to put my meter in diode mode, and that's with the arrow facing to the right. That's a symbol for diode mode. So I'm going to put my red lead on the right side of the leg and my black lead on the middle. 0.5, that's good. And then this one, next one, 0.4 is good. So anywhere between 0.4 to 0.7 is good. This one I'm going to flip over. I'm going to test these. 0.2 is low, and that's low. Check this one. That's a short, and that's a short. So I'm going to take these out of circuit and see if these are good or bad. It's near a transformer, so sometimes the transformer may seem like the surrounding parts seem shorted. You can take it out of circuit, it should read good. Right here on the board, there's a fuse, and I know it's a fuse because it's labeled F2. So you check that, and F2 should read a straight short signal. So you should get a signal out of that, and I'm getting open line or open loop or over limit. But looks like the fuse is bad. So if this fuse is bad, surrounding part probably took the fuse out. So we're going to replace these two transistors if they read shorted. So let's go ahead and take them out of circuit and read them one more time. And you want to heat up the pins until they liquefy. Use a solder sucker and suck out the solder. So we're going to read it in diode mode, and we're going to take the transistors that we took out, and we're going to put my black lead in the middle, on the middle leg, and my red lead on the outside. And it reads 0.001, that's a short signal. That would take out a fuse. And then leave my black lead in the middle again, and put my red lead on the outside leg, and another short signal. So no matter how I test this, it's sending a short signal, basically garbage. And this is a MOSFET, N-channel MOSFET for it's maybe less than $5. So between these two transistors and a fuse, you're looking at under $20 with shipping, I guess. So we're going to do the same thing here. Put the black lead in the middle, the red lead on the outside, and I get OL, open line. And do the same thing on the outside. I get 0.2. 0.2 is not good. It should be reading between 0.3 and 0.7. And then I'll switch my red lead in the middle, read the outside leg, and 0.2 again. It shouldn't read both ways. It should only read one way. We're going to replace these two. Actually, this one's crumbling. I don't know if you can see that, but there's a crack in it. I don't know if you can see that. I don't know. But anyway, you look at the part number, and the part number is FQPF 9N50C. So here's the parts that I tested, and they were all bad. Bad fuse, bad bridge rectifier, and 2 bad transistors, which are identical parts. So I'm going to go ahead and replace those and see if the TV works. And when you get the new parts in, don't forget to put heatsink compound on the back of the parts, like that. Basically, what that does is it helps transfer the heat from the transistor or the bridge rectifier to the heatsink, which makes this last longer. And let's go see if that fixed the issue. So I'm going to go ahead and turn on the TV, and let's see if the TV turns on now. I hear a bunch of noise. And there we go. I'm going to turn off the lights so you guys can see the TV. And there it is. The TV's working. So if you do have standby voltage going to the main video board, then I would change out the main video board. And you can get the parts at shopjimmy.com. So if this video helped you out, go ahead and give me a thumbs up. And if you know anyone this video may help, go ahead and click on the share button below and share it to Facebook or G+. Or even if you have a tech blog, share the link to your tech blog. And thanks for watching, and subscribe to Tampa Tech for more tech reviews coming your way. Later, guys.